Section 11.7, standard deviation. So 11.7, we're talking about standard deviation. And I'm even going to go in here, I'm going to slash, and I'm going to go variance. Okay, because these are two things that we'll be covering in this section. Now, we've talked about measures of central tendencies and dispersion in there a little bit with the range. The standard deviation really is another way that we start talking about a variance, okay? So the variance is part of the standard deviation. We actually find the variance first, and then we find the standard deviation. So do realize that the standard deviation or the variance talks about how our data spreads from the center. So it talks about how we disperse out from the center, once again, given a mean value. Okay, so standard deviation is generally denoted, once again, for a population by sigma. Now I say population because there are times we use a lowercase s. That's for a sample. You will not see that until elementary statistics. We're just covering about the basics of standard deviation and some of the stuff that goes into it. Okay, so this is our standard deviation. I'm just going to go standard deviation. And then sigma squared is our variance. So if you want to think about this as something, basically the square root of the variance equals the standard deviation, right? If I have something squared and then now it's not squared, I took the square root to get here. So that's what this is really starting to discuss. Now, how do we find the variance? Okay, so the variance equals the summation of all x minus x bar squared over n. Oh yeah, a lot of stuff going on here. But what this is talking about, x means each data value. Okay, x bar is the mean of the data, and then n is the number of data. So basically what we're going to do is we're going to take our set of data, we're going to find our mean. Okay, once we find our mean, we're going to take every x, subtract the mean, and then square that answer. Whatever the number is, minus the mean, square it. Number minus mean, square it. And we're going to write down all these numbers, and then we're going to add them all together, because that's what this summation is. We're going to add all this together, and then we're going to divide by the total number here, and that gives us our variance. And then our standard deviation is going to be the square root of whatever this number is right here. Okay, so this looks very complicated. It's time consuming, but do realize it has very particular meaning in real life, and once again we'll see this in our next sections as we keep moving along here. You'll see it a little more. So let's start by looking at number 8. Okay, really I'm only going to do one example for you today because it's the same thing repeat, same thing repeat, same thing repeat. So let's go to number 8. Number 8 gives us the numbers 12, 3, 2, 4, 5, and 7. Okay. It tells us let's find the variance, or mean, variance, and standard deviation. So we want mean equals variance equals standard deviation equals. Okay, or I could have went x bar, sigma squared, and sigma. Could have been my abbreviations because that's what they mean towards. So let's go like this, and I'll put these in parentheses because this is my mathematical meaning. So what we want to do is we want to find that mean first. So once again, in order to find the mean, we're going to add all our numbers together. So we take 12 plus 3 plus 2 plus 4 plus 5 plus 6. That equals 33. And then we're going to divide it by the amount of numbers we have, which is 6. We see that we get 5.5. Okay, now once again, we're going to decimal in here. We could leave as fractions, but there's going to be a lot of calculator work as we get into this. Now, I have most calculator work done for us so that we can see that just kind of move into our problem. What we're going to do now is I'm going to tell you the easiest way to do this is we will create a table. So you'll go 12, 3, 2, 4, 5, 7. Now, You do not have to have these listed in order. That's a nice part about standard deviation. Unlike the median where they have to be in order, standard deviation we can have whatever we want because we're not worried about the actual order that data happens. It could be presented in any order out there. What we're going to do is we're going to create this overall table. Okay, so these are my x values, the 12 right here. What I'm going to do now is I'm going to take x minus x bar. So I'm going to take 12 minus 5.5. So 12 minus 5.5 is 6.5. 3 minus 5.5, so 3 minus 5.5 is negative 2.5. 2 minus 5.5 is negative 3.5. 4 minus 5.5 is negative 1.5. 5 minus 1.5 is a negative 0.5. 7 minus 5.5 is 1.5. Then I'm going to take each of these values and I'm going to square it. Okay, so what I probably would have done is I would have took 12 minus 5.5, I got 6.5, and then squared it, and then wrote 42.25. Then I would have took 3 minus 5.5, and then squared it, and we get 6.25. Okay, because negative 2.5 squared is 6.25. Do realize that in this summation, we're squaring whatever this difference is in here, so it's always going to be a positive value for what we have here. So then this is 12.25, 2.25, 0.25, and then 2.25. Now what we want to do is we want to take the summation of this. Okay, so the summation of this, once again going back to this formula, the summation of my x minus x bars squared. Here's my x minus x bars squared then, or all these numbers. We're going to add up all these numbers. So if we add up all these numbers, we get 65.5. Now, to find our variance, we have 65.5 divided by 6. So this is 10.916 repeating. And then our standard deviation is going to be the square root of what this is. So if you have this in, you take just the square root of that whole number. Don't use any rounded numbers. Do this exactly as best as possible. We want to try not to round. In which then we get 3.03, let's see here. Oh, I'm sorry, 3.30, dyslexia kicking in there. Messing my numbers up, 40. So here we could go 3.30. Once again, about 2 decimal places is a good value to stop at. Generally, the rule is 1 more than what our data is presented, so 1 decimal place would be fine. Now, the meaning of this standard deviation, it has very distinct values in here. Okay, so once again, we have our 3 answers for this part, and that's all this section is discussing, is how do we find basically that standard deviation. And this is a process that we have to go through. Now, as more numbers appear, and maybe this mean isn't as nice, that means these numbers get to be pretty ugly to work with, but do realize, write the table out, work through it. It gets better. Those of you going on and want to move forward in math classes, calculator does this for us. It's a great thing. But you don't have that option right now. Later on, we'll talk about a normal curve and the meaning of this standard deviation. Basically, when we talk about standardized tests, there's also a standard deviation that's presented on that test for you. There is a distinct meaning to that. We'll be discussing that later, but for right now, this is all this section is covering, is how to find the mean, variance, standard deviation. Okay, so the variance, standard deviation are only 2 new things here.